Today's lesson will focus on probability as a fraction. The objective of this lesson is to represent probability outcomes as a fraction. This is the third lesson in topic 20 of Envision. First, we need to begin by understanding outcomes. What are the possible outcomes of an event? There is an impossible outcome, a certain outcome, an unlikely outcome, a likely outcome, or an equally likely or unlikely outcome. And that would be half. So when we talk about will something happen, it can happen anywhere along this spectrum or this line. So what is the likelihood that your fourth grade year will come to an end? That is certain. What is the likelihood that you will sprout wings and fly? That would be impossible. What is the likelihood that if I give you a quarter, you will flip heads? That would be equally likely and unlikely. Half. So, when we talk about outcomes, we will talk about them in these terms. Let's begin by talking about problem solving. Ms. Tritch is organizing t-shirts for 8 students of the Winter School After School program. She has 3 different colored shirts, blue, orange, and yellow. Without looking, what is the probability that she will pick a yellow shirt? Well, I know that there is a blue, orange, and a yellow. There are 8 students. Blue, orange, and yellow. If I just picked and there was one of each, they will all have an equal chance of being picked because there is one of each. But it doesn't say how many of each there are based on this problem. So I don't know if there's one of each, 2 of each, or more of one than there is another. So that would change my probability of selecting a certain color shirt. So let's see if that would change if I had more of one than another. So for the yellow shirts, there are 5. For the orange shirts, there are 2. And for the blue shirts, there's 1. Now I know that there's 5, 6, 7, 8 shirts. There's enough shirts for everybody, for all 8 students. What is the probability, though, that without looking, Ms. Tritch will pick a yellow shirt? Well, I see that there's more yellow shirts than orange and blue put together because there are 2 orange and 1 blue shirt, and that makes 3 together, and there are 5 yellow. So I think that there's going to be a higher probability of picking a yellow. But what would that look like if it was a fraction? So the first thing I need to do is total up how many shirts I have. 1, 2, 3, 3 and 5 is 8. So my total number of shirts is 8. That's my total. And the number of yellow that I have is 5. So the probability of picking a yellow is 5 over 8. Now what would be the probability of picking a blue shirt? The probability of picking a blue shirt would be 1, because there's 1 out of 8. What would be the probability of picking an orange shirt? I see that there's 2 orange shirts out of 8. And I notice that I can simplify 2 8s because I can divide 2 by 2, which would give me 1, and I can divide 8 by 2, and I would get 4. So that is how you represent probability as a fraction. The number of the outcomes, so in this case yellow, over the total number that you have. So let's see what that looks like with some of our shape tiles. Find the probability of selecting at random. At random means without looking. A tile from the tile shown below. Write the answer as a fraction. So the first thing I need to do is I need to count up and find my total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that there are 12 color tiles. Shape tiles. Now I'm looking for crescent. So crescent is a moon. 1, 2, 3, and there are 3. So 3 out of 12. That is the probability of me selecting a crescent tile from the 12 that I have. And I can simplify 3/12. I can divide 3 by 3 and I would get 1, and I can divide 12 by 3 and I would get 4. So that is the probability of selecting a crescent at random. Let's try a diamond. What is the probability of selecting a diamond? And I see that there are 1, 2, 3 out of the total, which is 12. And again, I notice that's the same as over here because I can divide 3 by 3 and 12 by 3. So my simplified fraction is 1/4. So that is the probability of selecting a diamond from my shape tiles. Now what is the probability of not selecting a circle? Of not selecting a circle. This is not a circle, not a circle, not a circle, not a circle, not a circle. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 of them are not a circle out of 12. And I can simplify 8 and 12 because they're both even by 4. 8 divided by 4 is 2. And 12 divided by 4 is 3. So either one of these would be the correct answer for the probability of selecting a shape tile that is not a circle. So let's look at the last one, a heart or a crescent. A heart or a crescent. So 1, 2, 3, 4. 4 are either a heart or a crescent. 4 out of 12. And I can simplify that, 4 out of 12. And I can simplify that because I can divide 4 and 12 by 4. And that would be 1/3. And that's how you represent probability as a fraction. First, you'll need to find the total, and then you will need to count up how many the total is that you are looking for. In this case, it was crescents. In this case, it was not a circle. In this case, it was a diamond. In this case, it was hearts or crescents, so that meant I had to count both, and that would go on the top. Now it is your turn. Please do all of the items shown, 8 through 15. Write the probability of selecting without looking. Remember, that means at random, the card or letter described. And in box 4, please describe an event that is certain and an event that is impossible. That is all for now.